Good morning, students. The last class we have completed electric intensity due to dipole at a point on the axial line. After the completion of the equation, we have got the final equation E equals to 1 divided by 4 pi epsilon naught 2p by d cube. Then after that, we come across the next fundamental equation for the electric dipole, that is electric intensity due to dipole at a point on the equatorial line. Now here the figure is important. If you neatly understand the figure, there will be no need of behatting the derivation. So I go for a representation of the figure. Just to understand the figure clearly. If you understand the figure clearly, then there will be no bother about the steps of the derivation. Shall I go for the figure? Yes. So I need the dipole. I take the dipole minus q and plus q. Now these are the two equal and opposite charges separated by a small distance. I place the charge at the points A and B. O is the center and separation distance is the 2L, and each charge from the center is at a distance L meter apart. Right? Now this is our electric dipole. I need equatorial line. What the equatorial line tells? So according to the definition, the line perpendicular to the dipole axis and passing through the center of the dipole is known as equatorial line. Now this is the dipole axis, center. Now this is the equatorial line perpendicular to dipole axis and passing through the center. Now this is nothing but your equatorial line. The electric intensity at a point on the equatorial line. Now this line can be extended at any distance, but I want to choose the point C. C is the point where the electric intensity is to be determined due to this dipole on the equatorial line, which is at a distance d from the center of the dipole. Is it clear? Then we know that wherever the electric intensity is to be calculated, to identify the existence of the electric field, I need what? Test charge. Now this is the point I want to calculate the electric intensity, so I place the test charge. So I place the test charge Q naught equals to plus 1 coulomb. Right? Then according to the Coulomb, positive force of repulsion. Now this is the line joining of the two charges. Now this is the force of repulsion. Now this force is nothing but electric intensity. So due to positive charge, I call this is E1. Right? Then this is a line joining the two charges. Then negative positive force of attraction. So this force is nothing but electric intensity. It is due to what? Negative charge. I call this is E2. When I join the charge minus q and the test charge q naught and plus q test charge q naught, it makes at an angle. Now this is theta. Theta is the angle made by the each charges to the line joining the test charge and the source charges plus q and minus q of the dipole. Then from the Pythagoras theorem, these two are at equidistance. AB equals to BC. According to Pythagoras theorem, BC square equals to OB square plus OC square. I need BC. BC equals to under root of OB square plus OC square. Then I can write under root of D square plus L square for this also. Isn't it? Then I resolve this E1 and E2 into two components according to resolution of the vector. E1 is resolved into two components. One is horizontal component, another one is vertical component. Now this is a vertical component. Now this is theta, corresponding angles are equal. This is also theta. So along the direction of the theta, now this is nothing but E1 cos theta. And what about this? E1 sin theta. Is it clear? According to the resolution of the vector. And again I resolve the E2. It is also resolved into two components. One is horizontal component Another one is vertical component. Alternative angles are equal, Z formation. This is theta, this is also theta. So, along the direction of theta, this is nothing but E2 cos theta, and this is nothing but E2 sin theta. Is it clear? Then, so after resolving E1 and E2, we got the components E1 cos theta and E2 cos theta. They are in the same direction. But these two are E1 sin theta and E2 sin theta. They are equal in magnitude but opposite in direction. Hence, they cancel out. E1 sin theta and E2 sin theta get cancelled. When the two vectors are in the same direction, now this is the resultant. Now this is nothing but resultant electric intensity. Now I call this is ER. When the two vectors are in the same direction, resultant is sum of their magnitudes. Here E1 cos theta and E2 cos theta are in the same direction. Hence their resultant electric intensity ER is equals to sum of their magnitudes, that is E1 cos theta plus E2 cos theta. Now this is our figure. Just to glance the figure. So I need the electric intensity due to dipole at a point on the equatorial line. C is the point on the equatorial line, which is at a distance from the charge plus q and minus q at a distance d square plus l square, which is under root. Then I place the test charge at C, q naught, that is equals to plus 1 coulomb. According to Coulomb's law, positive force of repulsion. Force is nothing but here electric intensity. E1 is the electric intensity due to charge plus q, and E2 is the electric intensity due to charge minus q, negative positive force of attraction. E1 and E2 are resolved into two components. One is horizontal component, another one is vertical component. For E1, the resolved components are E1 cos theta and E1 sin theta. Similarly, for E2, so resolved components are E2 cos theta and E2 sin theta. So, both the charges from point C are at equidistance. Hence, their electric intensity is also same, because charge is same, distance is also same, intensity is same. Hence, E1 equals to E2, that is nothing but E1 sin theta and E2 sin theta acting at a point C, which are equal in magnitude but opposite direction. Hence, they cancel out. Then what are the things remaining? E1 cos theta and E2 cos theta. So when the two vectors are in the same direction, what is the resultant? Sum of their magnitudes. Hence, I can write the resultant electric intensity ER equals to E1 cos theta plus E2 cos theta. Are you getting the point? E2 cos theta. E1 cos theta plus E2 cos theta, because they are in the same direction. Now this is my resultant. So how this equation comes, if you want to have the d under root of d square plus s square in triangle ABC, in right angled triangle ABC. So what is that? BC square equals to OB square, sorry, OBC, not ABC, shall I write here? OBC, right. BC square equals to OB square plus OC square. Is it clear? So I need BC square. Is it? OB square is nothing but L square and D square. I need BC. BC equals to under root of L square plus D square. Is it clear? No, I have written directly here. Then after this, the point C is equidistant from positive minus q and plus q of the electric dipole, and they are equal in magnitude but opposite in nature. Hence, E1 and E2 are equal in magnitude. So it means that E1 cos theta and E2 cos theta are equal in magnitude. Therefore, E1 cos theta is equals to E2 cos theta. Then I can write ER equals to E1 cos theta plus E1 cos theta. You can replace instead of E1 by E2 also. Then what is that? Resultant electric intensity. 2E1 cos theta. Is it clear? Just you glance the steps. Then we know that electric intensity E equals to 1 divided by 4 pi epsilon naught charge by distance square. So I go for E1 to 1 divided by 4 pi epsilon naught charge Q. Distance, what is that distance? Either BC or AC. I take BC square, distance square, into cos theta. Are you getting the point? So we are dealing with the positive charge. Either you can take the positive charge or negative charge. Magnitude is always positive because electric intensity is vector quantity. But in triangle OBC, I need cos theta. Cos theta equals to adjacent side OB by hypotenuse BC. What is OB? L divided by under root of L square plus D square or D square plus L square. You can write. Shall I substitute here? Everything will be aside just to see the figure. So the resultant electric intensity ER equals to 2 1 divided by 4 pi epsilon naught Q as it is. What is BC? So here BC square equals to L square plus D square. Shall I write? BC square, that is nothing but BC, we know that. What is BC? Under root of L square plus D square square. What is cos theta? L divided by under root of L square plus D square. Is it clear? Yes. Then I solve the equation. ER, resultant electricity, 1 divided by 4 pi epsilon naught. Shall I write Q into 2L divided by, so after squaring this root, what is the value? Simply L square plus D square. Then shall I write root is nothing but power, L square plus D square, power half. Nothing should be there. What is the existence? 1. When the bases are same, the powers are added. Hence I can write the final equation, ER equals to 1 divided by 4 pi epsilon naught Q into 2L, that is nothing but P. So shall I write D square plus L square or L square plus D square, 1 plus 1 by 2. This is 3 by 2. Shall I write one more step? 1 plus 1 by 2. Right? Then final equation. So resultant electric intensity ER equals to 1 divided by 4 pi epsilon naught P divided by D square plus L square to the power 3 by 2. Now this is our equation. Just to glance almost all the steps, then we come across the finalization of the last step. Is it clear? So I compare the distance. This is D. I can shift the point anywhere else along the equatorial line, but L should be remains constant. 2L itself is a smaller value. Thus again I made the 2L should be what? Half, that is L. The smaller values again its small value. If you take the square of the smaller value, that is again too small. Hence here D is far greater than L. D is far greater than L. Hence L square is neglected. Square of the smaller value is what? Too small. Hence my final equation, shall I write here? Resultant electric intensity ER equals to 1 divided by 4 pi epsilon naught P divided by, this L square is neglected. What is the remaining factor? D square to the power 3 by 2. These two get cancels. The resultant electric intensity 1 divided by 4 pi epsilon naught P by D cube. This is my final step. Now this is our 5 mass derivation. Electric intensity due to dipole at a point on the equatorial line, that is 1 divided by 4 pi epsilon naught P by D cube. Just, is it clear? Yeah. Let me explain once again. Whenever you come across this derivation in the examination, you neatly understand the figure. So I take the dipole, minus q and plus q. The separation distance is 2L. each charge from the center of the dipole is nothing but L. I need the equatorial line. The line perpendicular to the dipole axis and passing through the center of the dipole is called equatorial line. I want to calculate the electric intensity at a point C, which is at a distance d meter apart from center O. Then, wherever the existence of the electric field, that should be confirmed with what? Test charge. I place the test charge Q0. So, according to Coulomb's law, positive force of repulsion. That force is nothing but intensity. What is that basic concept? E equals to F by Q0. Q0 equals to 1. E equals to F. I replace that force by intensity due to positive charge, that is E1. Similarly, Q0 is positive and minus Q is negative. There is a force of attraction. That force is nothing but intensity. So E2 is the electric intensity due to what? Negative charge, minus Q. So E1 and E2 are resolved into two components. One is a horizontal component, another one is a vertical component. After the resolution, the vertical components are equal magnitude but opposite direction, hence they cancel out, and these two vectors are in the same direction, hence they are get added according to the vectors. So the resultant electric intensity at a point C, ER equals to, so E1 cos theta plus E2 cos theta, where E1 and E2 are equal in magnitude. Hence E1 cos theta is equals to E2 cos theta. I replace E2 cos theta by E1 cos theta. That is nothing but 2 E1 cos theta. Then I come across here. I need cos factor. In triangle OBC, you consider either of the one right angle triangle. Cos theta equals to OB by BC, L divided by L square plus D square. That is in under root. Then I substitute here. So after substituting the value of BC square, that is nothing but, so this is the root, square of the root is nothing but, root get cancels, L square plus D square. I remove this root, root is nothing but power half. Bases are same, powers are added. Then final equation, 1 divided by 4 pi epsilon naught, P divided by under root of D square plus L square, that is in the bracket, D square plus L square to the power 3 by 2. Then I consider the condition, here D is far greater than L. If D is far greater than L, here, if you consider, then L square is smaller value. Square of the smaller value is again too small. Hence L square is neglected. Now this is our final equation. 1 divided by 4 pi epsilon naught P by D cube. Now you can write simply this resultant electric intensity for the identification. So E equatorial line EQ is equals to ER. Both are same. We can easily represent, you can easily identify it EEQ or ER equals to 1 divided by 4 pi epsilon naught P by D cube. Is it clear? Yes. So after drawing the figure, after understanding the figure, after drawing it, then you can make your own sentence. Don't go for directly to the derivation steps. So directly steps को गए तो क्या होता? कुछ नहीं होता. At the time of solving the question in the examination, they needs a certain explanation. बात करने की ज़रूरत नहीं है. Consider dipole of dipole moment P. यहाँ पे mention नहीं करे, पूरे गड़बड़ होता बोल के. That is understood. So C is a point on the equatorial line at a distance d from the center of the dipole, where the electric intensity is to be determined. E1 and E2 are the electric intensities due to the charges plus Q and minus Q, and they are get resolved after the resolution. The resolved components are as shown in the figure. Then you go for derivation steps. Is it clear? समझ में गए? हाँ. Shall I compare both the electric intensities on the axial line and equatorial line? Then I come across how they are related. निकाल सकते हो फिगर को? Figure is important. Derivation steps कुछ भी नहीं है. Everything will be easy. Just you concentrate the things in proper way. Right? निकाल सकते हो फिगर को? Right? Shall I go for comparison of both the electric intensities, what we have derived last class and today's class? Yes. So I go for comparison of both the electric intensities due to the dipole. One is calculated on the axial line, another one is on the equatorial line. दोनों को comparison करेंगे. Then what that comparison tells? So electric intensity on the axial line is equals to what we have got the equation, 1 divided by 4 pi epsilon naught 2p by d cube, where d is the distance from the center of the dipole. Then let electric intensity due to dipole on the axial line 1 divided by 4 pi epsilon naught 2p by d cube. Shall I write equation number 1? Now what the derivation we have done? Now equatorial line 1 divided by 4 pi epsilon naught p by d cube. Shall I call equation number 2? Then I take consider. First equation consider कर लेता हूँ मैं. Electric intensity on the axial line 1 divided by 4 pi epsilon naught. Shall I write p by d cube? ये इसको दूर लिख दूँ मैं into 2. वही है same. Then what is this p by d cube? 1 divided by 4 pi epsilon naught. So this complete bracket represents what? Electric intensity on the equatorial line into 2. Therefore electric intensity on the axial line is 2 times electric intensity on the equatorial line. This is our relation. The electric intensity on the axial line is 2 times the electric intensity on the equatorial line. Or electric intensity on the equatorial line is equals to half of the electric intensity on the axial line. ऐसा भी लिख सकते हैं. Electric intensity on the equatorial line is equals to half of the electric intensity on the axial line. Is it clear? Now this is the relation between the electric intensity due to dipole on the axial line and equatorial line. देख लो पूरे दोनों इक्वेशन प्रूव करे सो है. जस्ट दोनों इक्वेशन को एक प्रूव करने के बाद उसको रिलेशन एस्टैब्लिश करने के लिए यू कंसिडर द फर्स्ट इक्वेशन, राइट विथ neatly, then you substitute this complete bracket indicates what? Electric intensity on the equatorial line. Then what the equation tells? The electric intensity on the axial line is equal to 2 times the electric intensity on the equatorial line, or the electric intensity on the equatorial line is equal to half of the electric intensity on the axial line. Now these equations are helpful while calculating the electric intensity due to dipole on the axial line and the equatorial line. Directly axial line पे दिए सो है what is the electric intensity on the equatorial line due to dipole. At the time you can take this equation, right? अब दोनों equation remember करने के लिए general equation एक आ जाता. It is not mentioned in the test book. Just we have got the in higher version books we have got the equation. आप याद करने के लिए extra information. Extra information. The electric intensity due to dipole E equals to 1 divided by 4 pi epsilon naught P under root of 3 cos square theta plus 1. 3 cos square theta plus 1. अब इसको इक्वेशन को मैं क्या कर सकता हूँ, मैं एक्सियल लाइन भी लिख सकता हूँ, मैं इक्वेटोरियल लाइन भी लिख सकता हूँ. फर्स्ट वन फॉर एक्सियल लाइन, when you consider the point on the axial line, what is the angle made by it? Theta equals to 0. When you substitute theta equals 0, cos 0 equals to 1, cos square 0 equals to 1, 3 plus 1, 4. What is that equation? Electric intensity on the axial line 1 divided by 4 pi epsilon naught P under root of 3 cos square 0. Cos square 0 is nothing but 1. So that is nothing but divided by, just I have to write the equation, that is nothing but d cube. So this d cube as it is 2p by d cube. इक्वेशन को करेक्शन करें, d cube नहीं लिखे थे, करेक्शन जनरल इक्वेशन में. अगर मैं इक्वेटोरियल लाइन लिया फॉर इक्वेटोरियल लाइन, what is the theta here? Equatorial line, theta equals to 90 degree. What is cos 90? 0. Right? 3 into 0, 0. 0 plus 1, 1. Under root of 1 is 1. That is equation. Electric intensity on the equatorial line 1 divided by 4 pi epsilon naught P by d cube. सही है? These are the equation. Just by knowing the general equation at the time of NEET or CET, we can go for what? Electric intensity on the axial line and equatorial line. ये हम लोग prove करे सो है. This is our equation. 1 divided by 4 pi epsilon naught You can write P by D cube अंडर रूट ऑफ 3 cos square theta plus 1. ऐसा भी ले सकते हैं ना, यहाँ पे लिख सकते हैं फॉर एक्सेल लाइन थीटा इक्वल्स टू 0, cos 0 इक्वल्स टू 1, 3 plus 1 4, अंडर रूट ऑफ 4 इज नथिंग बट 2. फॉर इक्वेटोरियल लाइन थीटा इक्वल्स टू 90, cos 90 is 0, अंडर रूट ऑफ 1 is 1, P by D cube. So right. Now this is about what इक्वेटोरियल है, वो एक्स्ट्रा इन्फॉर्मेशन में ऑलरेडी हम प्रूव करें. सो हमारे पास इक्वेशंस है वो, दैट इज द जनरल इक्वेशन. P by D cube जाके सेपरेट भी लिख सकते हैं, दोनों इक्वेशन वही हो जाता है. Shall I go for last derivation for electric dipole? Torque on an electric dipole. When the dipole is placed in the uniform electric field, it experiences a torque. Shall I go for that last derivation for electric dipole? Torque on a dipole. Yes. I want to calculate how much torque is experienced by the dipole when it is placed in a uniform electric field. We know that. What is that uniform electric field? The electric field is the same at all the points in equal in magnitude as well as direction. Then such region represents what? Uniform electric field. Torque on a dipole. What is my heading? Torque on a dipole. Or dipole is placed in the region of uniform electric field. What is the torque experienced by it? So, to have the torque on a dipole, I need the uniform electric field. How the uniform electric field is represented, we have studied in the earlier class. The uniform electric field is represented by set of electric lines of forces. Now these are the electric lines of forces. Set of electric lines of forces which are equispaced and they are in the same direction. Now this is the uniform electric field. Is it clear? Then I place the dipole. Now this is the dipole. This is minus q and this is plus q. Two equal and opposite charges separated by small distance 2l, which makes a certain angle theta. Theta is the angle made by the dipole with the direction of the uniform electric field. Right? I call this is the position A and this is position B. Right? We know that when the charge is in the region of electric field, E equals to F by Q. Right? Then F equals to E into Q. When the charge is in the region of electric field, it experiences the force, positive charge plus Q. Then I can write F equals to plus EQ. When the charge is in the region of electric field, it experiences the force. Positive sign indicates that the direction of the force is along the direction of the electric field. So the charge is in the region of electric field, it experiences the force. That positive sign indicates what? The direction of the force is along the direction of the electric field. F equals to EQ. Right? Similarly, if I take minus charge, minus Q, this is minus EQ. When the charge is in the region of electric field, experience the force. Negative sign indicates that the direction of the force is opposite to the direction of the electric field. Now this charge experiences the force. Now this is the direction of the electric field, opposite to the direction of the electric field, F equals to. They are equal in magnitude but opposite in directions. Hence the resultant is 0. But these two, what is the resultant force? That is nothing but 0. So these two forces are equal in magnitude but opposite in directions, but they are acting at different points. Hence there is a constitution of what? Torque. So to have the torque, I drop the perpendicular from this force and extend this force. Now this is nothing but the perpendicular distance for both the forces. Now for this force, this is a perpendicular distance. For this force, this is a perpendicular distance. So theta. Now corresponding angles are equal, theta. I call this is C. Is it clear? Then I go for calculation of the torque. Then how to write the explanation? Consider a uniform electric field in which the dipole of electric dipole moment P is placed and the 2L is the dipole length. When the charge is in the region of electric field experience the force, the two forces are equal in magnitude but opposite in directions. So both the forces are acting at two different points. They constitute a couple or torque that makes the dipole to be rotate. Now this is the center. From the center the dipole is rotating. So when the dipole rotates in the region of electric field, there it experiences what? Torque. Then the torque experienced by the dipole, we know that from the first PUC, the torque tau equals to either force into perpendicular distance. Is it our equation? First year we have studied in rotational motion. Then I go for the figure. What is that either force? Torque tau equals to either force, kaun sa bhi le lo, F. What is the perpendicular distance? Now this perpendicular, for this force perpendicular distance is BC, for this force perpendicular distance is BC. So perpendicular distance is BC. I need BC. Then I go for the triangle. In triangle ABC. So I need this BC. I know this AB. So for this triangle, this is hypotenuse. For this theta, it is nothing but what? Opposite side. So I go for sine theta. Sine theta equals to opposite side BC by hypotenuse AB. Then BC equals to AB into sine theta. What is AB? AB represents what? Dipole length 2L. So BC equals to 2L into sine theta. Is it clear? Yes. Then I substitute torque tau equals to force. What is BC? 2L into sine theta. So what is F? F equals to E into Q. Shall I write torque tau equals to E into Q into 2L sine theta? Shall I write Q into 2L? What this indicates? Dipole moment. Therefore, torque tau equals to E dipole moment Q into 2L P sine theta. So, shall I write P sine theta? I am representing magnitude. P sine theta. Now, this is nothing but the torque experienced by the dipole in the region of uniform electric field. Then, torque is a vector quantity. When it is a vector quantity, it has got the direction. Now, this represents what? Magnitude. So, direction. The direction of the torque is given by right-handed corkscrew rule, and it is perpendicular to the both the components P and E. So, यहाँ पे P है. If I take this one is, now this is the dipole moment P. Now this is E. The direction of the torque is, now this is the uniform electric field, and this is dipole. Wherever the existence of dipole, there is a dipole moment P. Now this is what? Torque tau. Torque tau equals to vector P cross vector E. That is nothing but P sine theta. Is it clear? Now this is nothing but the direction of the torque. Now this is theta. The direction of the torque is perpendicular to the both the component vector P and vector E. Now this is the direction. Now this is the magnitude, and its direction is determined by right-handed corkscrew rule. Normal derivation है, आराम से कर सकते. Just have to be understand the figure clearly. Then whatever the necessary things we are required, we have taken from the first PUC. Then we go for analyzing it. Everything will be made clear. उसके जो कुछ भी होना है यहाँ पे साइड पे पूरा है. So this magnitude, this equation represents magnitude. Now it is a vector quantity. Its direction is given by the torque is perpendicular to both vector P and vector E. Right? Now this makes the end of what? The electric dipole. नेक्स्ट क्लास में हम लोग वी कम अक्रॉस व्हाट, इलेक्ट्रिक फील्ड लाइंस, गॉस थ्योरम, एप्लीकेशन ऑफ द गॉस थ्योरम, राइट। आपको कुछ भी प्रॉब्लम्स है, कुछ भी क्वेरीज है, कमेंट बॉक्स में लिख सकते हैं, राइट। वी आर प्रोवाइडिंग द PDF notes for you after the completion of the whole unit. Is it clear? Yes. Thank you.